Hello everyone. Hello.
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 Yes, hello, sir.
Hello.
Hello,
Good
sir.
evening.
Good evening, sir.
Hello, sir. Good
Good
evening, sir.
evening, sir.
Hello. Hello.
Y-
Hello.
Just
Hello.
hello. Yeah. We'll start. Okay. Let's share my screen. Today we'll do revision on week 9 and 10, which has random variables, like introduction to random variable. Then we'll go to how to find expected mean and all variance. Is my screen visible?
Yeah, sir. With you.
Can start. So we'll cover week 9 and 10. Random variables on it. Okay. And we'll see how it is related to probability, and sample space, of course, event or a random experiment, sample space of a random experiment, right? Mm, Then we'll see we'll see few properties of it. Okay. Then we'll go and see how how to find expected value, expected value, or you can say expected, yeah, expected value or mean, same thing. And then we'll see how to find variance and standard deviation of random variable. Okay. So this will be the topic for today. So start. So what is a random variable? So prior to this, random variable, we had probability. So let's say you do have three coins, say, and you toss them. Okay, so this is my experiment that I have. I have three coins, and I'll toss them, and I'll note down it. Okay, and you can definitely do that and write the probability of getting a head or a tail. So each coin is a fair coin, and the outcome would be head or a tail. So you you can write. So these are questions are based on uh, how many heads. What is the probability of getting heads, right? Something like that. So yes, what is the probability of uh, getting head? Now it could be anything. Let's say head one, head two, head three, right? Something. So first we can write sample space of this. Let's say sample space. If I write, then that is going to be head, head, head. Then we can get one tail and say head, tail, head, tail, head, head. Right. Another would be say head, head, tail, s- head, tail, 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 head, tail, 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 head, and then at the last tail, tail, tail. Right. So this is my sample space. Right. Now, we are we know this. We can find out the probability out of it. So let's say probability of getting three heads. What would be that? You can get like total numbers of uh, total count of in a sample space, and what is our event is, right? That is getting three heads, and that is one by head. Another could be like, let's say, how to get two heads, right? Two heads in this. Then you can count wherever two heads are there. So here it's there, here and there. Like so, for like three possible ways, and total ways are eight. Right? So you know it, and you know how to do permutation combination also. So let's say uh, there are total eight ways, and if you want one head, sorry, all three heads out of three coins. So you can write 3C3, and this is going to be two heads out of three, right? So 3C2 by 8, and this is also same thing, right? 3 by 8, and you can say, let's say, three heads, which is also 3 by 8, right? So here, sorry, not three heads will be one head, one, two, three. That is also three, three, one, right? For we want one head only. Yes, and that is also by total ways, and then zero heads. that is 1 by 8. Here we are getting that, and PC 0 by 8. So you know how to do this all. This is just a probability. Now we are not.
Hello, is it me or everyone? Audio not audible?
Not
Sir,
audible.
your
So I
not
I
aud-
think we
Yes,
have
sir.
lost the connection. Sir, have lost the
We have
connection.
Sir, are you there?
Sir,
Sir, your voice is not audible.
We can't hear you, sir.
Hello,
sir, your voice is not audible.
Yeah,
hello.
now
yes.
it's
Hello, sir.
audible, sir.
Now,
Yes, sir, it's clear now.
Okay. Okay. It's that I was saying that.
Hello?
Sir, I
Sir,
think
again,
your
there's a
connection is
connection
not
error.
that good.
sir, again voice is not audible.
Again, connection is lost.
Hello, sir. You are not audible.
We can able to see your screen, but not your audio.
Hello.
Yes, now it's coming.
Oh, thank you. So know how to find the probability. Okay, we know find probability. We know, right?
Yes, sir.
So that is total ways out of the the whichever way we want, right? So total and upon, you can say, required something. But now we are much interested in numbers of it. So how we got this probability, that is not important. But when we can get this probability, like what is the outcome of happening this, right? Say cricket match series is, let's say 3 match series is there, right? 3 match series. Yes. And how can India win in this? So maybe they win the first one, second one, and the third one also. Basically, out of 3, they need to win 2 only. But still, let's say that's okay, right? They can win 2 and lose 1, still okay. They can win first one, lose second one, and then win third one. That is also okay. And let's say they lost the first match, then they won both of them. So this all the ways they can win the match, right? So uh, win the series, right? So now we are not much interested in how this happened, right? How what happened internally, but we wanted to know, did India win the series or not, right? So that kind of questions are now we are more interested. So that's where we wanted random variables. So uh, which will uh, which will help you make the probabilities, the samples in sample space. The each element was there. Now those elements will be converted to numbers, right? So let's say my experiment was, or my event is, number of heads out of 3 tosses. Okay? Fair coin. Fair coin and all. Okay. So let's say what could be the possibilities. Let's say I can get 0 heads. I can get 1 head. I can get 2 head and 3 heads. And what would be the probability of that? Uh, 0 heads is 1 by 8, right? We did it here.
Yes,
Uh,
sir.
okay. So 3 by 8
I think we lost the connection again, sir, maybe.
Are you speaking?
Yes.
Hello, sir.
Sir, are you there?
Sir,
Hello.
Hello, sir.
Yeah, now it's audible, sir.
I think sir lost connection.
Sir,
No,
you're
no.
Sir,
not
your voice
audible.
I
is on off.
am I audible?
Hello, sir.
Yeah, hello.
Sir. I think, sir, mic is not on. Or its connection is on.
Uh, okay. I think now it's audible. I don't see any.
No, it's not audible for me.
Yeah, audible, sir.
It's audible, sir.
yeah,
Audible,
now.
audible.
Audible, sir, on off.
But so this my event is how many heads out of three tosses. Now you can say something like so. So this will become my x, right? How many number of heads I can get out of three tosses, and for each of the you know outcome there is a probability associated with it, right? So x could be 0, 1, 2, and 3 in three tosses, and that has you can and you call this so first let's say what is x is a random variable, and you can say p of x is probability mass function. Probability mass function. So just remember that this
I think the voice is not coming.
Then we lost the
Sir, again,
Hello,
your
sir.
voice is not
Connection
audible.
poor. Sir, your internet connection is weak, sir.
Sir, your internet not work properly.
don't know why.
Hello, sir.
Hello.
Sir, screen is
Hello.
stuck, sir.
Yes.
Yeah, now.
Sir, your internet connection is not stable, I think, sir. Yeah, now it's
Okay.
coming.
Hello.
Yes, sir, you're
Yes,
audible now.
sir.
Okay. Am I audible? Okay, fine. Yes. So this p of x are probabilities of each separate events that of my uh, sample space should be one, right? So this all probabilities add up to one. Okay. And you know that probability can't be less than zero, right? That's not possible. And it can't be more than one also. But in our case, we only like in probability mass function, we only care that it shouldn't be like that is not possible that it is less than zero, right? So negative not allowed. So these are two properties you can say of a probability mass function. If it has to add up to one, and it shouldn't be less than zero. Uh, so that is a random variable. Then what we are next interested in a random variable is that what would be the expected value of this. So let's say this experiment is there of tossing three coins, uh, tossing three coins, right? What if you do this experiment, the whole experiment repeatedly, let's say 1,000 times, 10,000 times? What are you expecting? How many heads you are expecting, or what is the mean value of a random variable you are expecting, right? So that's what we call as expected value of a random variable. And so let's say I have this 3 coins. I'm tossing that. Same thing, head and tail possibilities. So expected value or expected mean, you can say, your mean, right? That is going to be summation of I from 1 to any different kind of the sites. So this is for discrete random variables. So currently in 9 and 10 we have discrete random variables. So for that, let me take something till k or something, and we'll take probabilities of, of that, and uh, xi. Okay, so or maybe you can say value of x is equal to, so x is this column, and xi is 0, 1, 2, 3, and something, right? So if I try to find my, you know uh, e of x, which is expected value, this how we'll represent this expected value e of x. Okay, then it is going to be uh, 0 times 1.8. So that is probability multiplied by the x value, plus 1 into 3 by 8, plus 2 into 3 by 8, plus 3 uh, into 1 by 8. So this is going to be 0, and this is going to be 3 by 8 plus 6 by 8 plus 3 by 8, and that is 12 by 8. Or you can divide it by 3 by 2, right? That is 1.5. So see, 1.5 doesn't mean that it's possible, right? It's not possible. What it mean is, if you do this experiment several times, right? Multiple. Let's say you do this experiment 10 times, right? This whole experiment, if you do 10 times, then you can expect that, 15 times you'll get the head, right? You can expect 15 times you'll get the head. Or if you do it 100 times, then you can expect that 150 times you'll get the head, right? So and you can see also, let's say I have this 3 coins, and let's say you do this experiment 10 times, right? So here, uh so how many total toss I did? 3 into 10, right? 30 time I tossed a coin. And from probability we know that out of 30 we are expecting, 15 time head to appear, right? So it does mean when you do this experiment several times. Okay, so that's what expected
For
value or expected
hello sir.
mean.
For
Yes.
short term, I mean, if experiment done 1 or 2 times, then experiment value, this expected value will be not average value, right?
No, you can't do that. No, see, probability you will only get when you have done this several times. If you do it once, let's say you do it once, how will you get the probability value? You'll not. You will. What you will get is that is
Let's
called
say twice we have done two
relativity.
times. Then,
Yeah. What is toy? Toss. No. Sorry, I didn't get it.
sir, if we perform an experiment twice, sir, then what is the expected value? It's average value, or
Uh, Toys. What is toys?
I mean 2 times. If we perform
Oh,
experiment 2 times.
okay. So then that's okay. No, you did it 2 times. You have to write what you have to write, like, only 2 times you did this same experiment. This experiment you're saying, or you tossed it 2 times. Which,
Sir,
so
it
this
is still,
whole thing.
sir, expected value still give the average value, or it's something else?
No, it will always give. So
When the number
expected
of
value
trails
is
is
always
more,
uh, Yes, it doesn't matter if number of trials are more or less. Why is that? Because we already said that this is probability, right? When will you get this as a probability? Because you already did it several times, right? Otherwise, you can't say this is a probability. What is the other term of this? Or maybe you are thinking a relative frequency. Let's say you twice. Let's say you have coin, right? You tossed it 3 times only. This is the only thing you did. Now, what could happen? You can like you toss it and you get all the heads, right? This can happen, and you can count it. Like, okay, this thing happened. Now, what is the probability in this? There is no variability, right? There is nothing changing there. You know the outcomes, and now you can't do much with it. So probability is when something is variable, something is changing, and something like that. Right? So if you can count it or something, then it will become relative frequency. But if you do it several times, something, and now it becomes like probability or something, right? Uh, that's what uh we can
Sir,
say. So let's
for
say
a
I have
longer run, sir, for a longer period of, for longer run in performing experiments, sir, relative frequency also become closer to probability, right?
yes, yes. So, but that's okay. But in longer run, right? So that's what we said that this is a probability. We never said this is a relative frequency. So if you do a longer run, then it will become a probability, and then you don't need to worry about that, right? So, are we going? Are we doing it multiple times or not? But what does this expected value mean is if we do this experiment multiple times, then you can say that I'm expecting 150 out of it, right? So let's say here 1.5 is expected value. It's not an integer value, right? Number of heads I'm expecting in a 3 coin. So this 3 points are there. I tossed it, and I'm expecting 1.5 times head to appear, right? That is not possible. Like really it's not possible, but I'm expecting that this will happen. So what this expectation mean is if I do this several times, then it kind of makes sense that if I do it 100 times, then okay, it makes sense that 150 times I will get head. So the understanding of that is this, that if
Sir, if
I'm
the
doing
experiment
experiment.
is not performed for longer run, sir, then we can't find expected value or it's
No,
something
you
like that.
can do it. So expected value is there, but it see the meaning of expected value has nothing to do with what is it possible in reality or not.
Sir,
You
excuse
can
me, sir.
find it
It's not
expected value.
clear. How you are saying if you are tossing it for 100 times, you will get 150 times head? I couldn't understand that concept actually.
No, not tossing it 100 times. If you do this experiment 100 times, this 3 coin toss experiment,
Okay.
then you
If
will
you
get
are
150 times. And
okay, repetitively this three got it.
yes. Any
Meaning the number of
experiment,
attempts will
any
be
experiment,
300 times.
yes,
Then it is
yes,
okay. Yeah.
So in this session, we are going to discuss previous year question paper.
yes, we'll do that. So,
Okay, sure.
so that is expected value or expected mean. Then, okay, so
Yeah.
we have this. So that is my PFX. Now, you can find variance of this. So variance, like if you do mathematically, that is going to like what we'll do. You take p of xi. Uh, you'll take p of I, but which is let's say 0 or something for first case, and then you'll take that xi value, and out of that you'll subtract p of x and square of it. Yes, and you'll take summation of. So that's how variance is. But for in like maybe sessions or in our course, it's being uh, taken as you can do v of x as e of x square minus e of x square, right? So this also you can find the variance of it. So variance is same thing, like we used to do in previously, right? That if you have this value something 1, 2, 3, 4, 5, 6, 7, right? Or they are repeating several times, then how will you find the variance? You'll take the mean, you will subtract out from all of them and sum it up, right? Uh, that's how we used to do it. And if you really expand it and think in this way, then you will come across this kind of equation. It's same thing, and it's just a further expansion of variance that you'll get this formula. I'll not do the derivation of it, but you can certainly do it. Okay. So let's find what is going to be variance of this. You can say um, 0 minus expectation of that, which is 1.5. We'll multiply by 0 plus 1 time 1 minus 1.5. 3 by 8. So here 1 by 8. P of I. Then here 1.5 whole square plus 3 by 8. 2 minus 1.5 whole square plus 1 by 8. And 3 minus 1.5 whole square. So if you solve this, what will you get this? Or maybe you can solve this way. 0, 1, 3 by 8, 1 by 8. If you do square of that is 0, 1, 4, 9. Right? So expectation of x square is going to be 0 into 1.1 by 8. 3, 1 into 3 by 8, that is going to 3 by 8 plus 4 into 3 by 8 plus 9 into 1 by 8. And you'll get 3 plus 12 plus 9 divided by 8. That is going to be 24 by 8 and 3, right? And expectation of x was, we already found 1.5. We have to square it, right? If you square it, I think 15 square is 225, and you'll get 2.25. So variance of x is going to be e of x squared. So expectation of x squared minus expectation of x to the power whole square. 3 minus 2.25. You can say 0.75. Right? So this is how you can find out variance of something. Now, you kind of get it that so the mean and variance are very similar to what we did in because week 3 or 4, that they are same thing. So let's say if you do uh, add a constant, like add a constant to all the what random variable x, right? Then how will mean change and how will variance change? So expected mean, and you can say variance of random variable, right? So expected value and expected variance of random variable, right? So how will this will change? Uh, so
Values
adding
won't
a
change.
yeah, so adding constant, then you can say that new expected mean is going to be expected whatever previously it was there. So maybe I'll write it say new. This is new, right? So new is older plus c, right? And variance will not change. It will be v of x only. Nothing will change there. And if you multiply a constant with x, right? So all the x's will be multiplied with some constant. Then what will you get in a mean? You will multiply same thing by previous expectation, right? This will you get. And how will variance change? C square times whatever previously it was there. So I don't need to write. So previously it was v of x, and then now you can say after multiplying you'll get c square times v of x, which was I think same thing as previously. And standard deviation you can maybe write that also. Standard deviation, yeah, I think new column, but standard deviation, if you add a constant, then it will not change. If you multiply, then it will change by c, uh, c of, let's say, maybe standard x, whatever previously. So these are few properties of if you add, if you multiply. Now, what will happen if you add two random variable? Let's say x is a random
Sir,
variable, y is a random variable. You can say yes.
Sorry to interrupt, but can you please define either we will get two different values from the two different formulas of variance you have told earlier,
No, you will get same value.
which was pi xi minus ex whole square and ex square minus ex whole square.
Uh, uh, yes, you will get same value. Yes, you will get the same value.
This
You
thing you
will
have
will not
written
get
1 by
different.
8 0 minus 1.5 whole square. This is
Where?
giving another answer
Where?
instead of that you have find out after it from the next method.
I don't think so. But solving this will be difficult. But this will give same value as this. I don't think so.
Okay, sir. Fine.
Yeah, maybe we can solve it later, but okay, it will give same thing.
Hello, sir.
Yes, yes. Yeah, hello.
I think your internet connection is quite weak.
Still, it's weak. Now, I know I wasn't speaking in between. Like for now,
Yeah.
just
Your voice is
to
breaking, sir.
my voice is breaking.
Yes,
No,
sir.
no problem.
And your screen was lagging too. It was not that smooth.
Okay, that could be possible. Sure, but okay, we'll see. Okay, lagging is fine. If my voice is breaking, then that let me know. I think lag will be there. Uh, let's say we have two random variables now. Okay, and you add them up. You can say anything. There's a tossing coin and something else, and then you add them up. Then yeah, so you have one random variable x and you have another random variable y. You add them up. Now I'm asking what will be the expected value of this of addition of both of them, right? Then that will be going to be you can add individual expected values of this. Okay, e of x plus e of y. That is that 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 you can do. So you can take two random experiments, random variables, and you can add them up. So let's say x is there, y is there, and maybe something like the x and then p of x, right? So something you'll get. Then let's say you have y and p of y also. So you have this PMF, right? You should have this PMF. I'm not writing anything, but you can say that x equal to 0, x equal to 1, something. Y is equal to 0, y is equal to 1. It doesn't need to be start from 0 or something. Let's say if it's starting with different value, that is still okay. 1, 2 or something. That is also okay. Then if you have all these probabilities and this what a random variable can take range of this, right? You have this all, and if you add them up, right? So if you add x plus y, then and then if I ask you what will be the expected value of that is equal to individual expected values. Okay. Now in terms of variance, if I ask you what will be the variance of x plus y, this is this only and only you can find out if x and y are independent. If they are not independent, let's say first random variable is not independent of another random variable, then you can't find it out. Why that is not in our course, like why is that? Maybe for advanced courses you can say it, but that is not required. But they should be independent. Okay, that is important. That they should be independent. X and Y. It should be independent. So if they are independent, then yes, you can find it out. Variance of x plus y, which is going to be addition of them only. If they are not independent, you can't find it out. Okay, so we have added them. We expected mean. No, I don't think so. There is anything left. So that's it. This all was there in week 9 and week 10. Yeah. One thing is that's CDF, right? Cumulative distribution function. So previously we had this 3 coins, we tossed it, and we said we can get 0 heads, 1 head, 2 head, and 3 head. Maybe you can say this is 1 by 8 and this is 3 by 8. Okay, this both are equal. So this is my this is we called as, maybe you can say PMF something, right? Probability mass function, represent in plot and all. But now we are interested in how a cumulative distribution function will look like. And why we need it is, let's say the question is find when will x be less than equal to 2, right? So you want to find out this, right? Which is less than equal to 2 is like this 3 bars, right? First 3. Or it could be, let's say, what is probably less than equal to 1. Then it is going to be this 2 charts, right? Except this. So this first 2 will be there. So this type of things we wanted to look into, that is cumulative distribution function. We are adding the PMFs of individual value of random variable, and then we are calling it as CDF. So if you kind of plot a chart for that, so let's say here, so let's say this is 0. It's starting with 0. The max or the range of CTF is till 1. Okay, till 1. That is the range of it. It can't go beyond. It will not take values beyond 1. And why is that? If you see, if I ask you what is the probability before 0, like what is the probability of getting heads less than 0, and you can say there is no way you can get less than 0 heads, right? So that's why till here it is 0 only, right? Till here it is 0. There is nothing to draw, and then at 0 it will spike, right? It will spike till 1 by 8. So you can say like this. Then let's say here it's 1 2, and this is 3. That many possibilities of x. You can say this is x. Then at 1 it will go 0 1 by 8 till 1. Then at 1 it will increase by 3 by 8, right? So 3 by 8, and this will make it how much? 1 by 8 plus 3 by 8, or you can say 4 by 8. Okay? So that much is it increased. Then it will go same till 2, because nothing to add, right? There is nothing like at 1.1 1.2 1.3, nothing there. So it will again increase by how much? 3 by 8. Okay? So this is going to be again addition of, like, you can say 1 by 8 plus 3 by 8 plus 3 by 8, right? That much at this value should. That will again go till 3, and it will increase by how much? 1 by 8, right? Uh, so that last value will become 1. So this final at top, you'll get this value as a 1. Addition of all of them. You can see this is how much is this? 6 7 by 8, right? This is 7 by 8. This is 4 by 8, this part, and this is 7 by 8, and this is 8 by 8. That is 1. Okay, and this is my, you can call this chart, this step function, you can call the step function as CDF. Okay, so if a question asks what is what are chances of getting p less than let's say x is less than equal to 2, then you can just see this chart, cumulative distribution function, and you can say that less than 2. Okay, less than 2 is this one, and then if you want equal to also, you can say this value, right? This value and less than, so that is 7 by 8. Then if it's asked what is less than 1, then you can say 4 by 8. And if it's asked less than 0, not possible, but equal to 0, 1 by 8, equal to 0, and less than 3, then all the things, right? So that is going to be 1. So from this also you can figure it out, this value, like what is probability of getting something, right? So that is 7 by 8. And this is very useful. We wanted to make a sample space into numbers. Now we are interested in when this is possible, right? Some this kind of conditions, when it is possible. We wanted 2 times to win equal to 2 times equal to 2 times 1 time something. So this all changes you can make, and you can find out probability of that. So that's why this CTF and PMF are important. Okay. I think that was all in week 9 and 10. Okay. We can take questions from last year, which were yes. So let's say this question is there. In a company, 120 employees are divided into 3 departments, right? So there is marketing, there's finance, then there is IT. Hello, am I audible?
Yes, sir.
Yes, sir, audible.
Okay.
Yes, sir, you are audible.
Okay. Then let's say the number of Employees in each department is as follows. So there are 36 in marketing. Then there are 40 in finances. And let's say there are 44 in IT. Okay. And total are 120. You can sum it up. That will give you good. So is randomly selected and an employee. So my experiment is an employee out of 120 is randomly selected for a presentation. Let X denote the number of employees in the department to which that employee belongs. Based on the given info, create PMF. Now you can definitely go and create as X equal to 1, 2, 3 and all, but that's what not we are interested in. We are interested when something is changes, right? So that's how we'll write the X also. Let's say X is first, you can say marketing guy, so 36, right? Then you can say X equal to uh, 40 and X equal to 44, right? And probabilities associated with that is P of X, you can say 36 out of how many? 120.
120.
40 out of 120 and 44 out of 120. So this is what I'm interested in. So this is how you can create this PMF. Okay. In quiz in Anthem, the options are given to choose out of this. Maybe you can solve it further. This is going to be 4 into 9 divided by 4 into 3 into 10. And this suppose okay, so that will give you 3 by 10.
Point
Here you can cut this off and 1 by 3. This is 411 by 30. And you can get probabilities of this. So this is P of X only. This I just solved it. And now let's say ask what is expected mean of this, right? So how will you find it? You'll use 36, that is X value, and you'll multiply by
3 by 10.
so it's still PIXI. Anyways, you write it. So or XIPA, right? So let me write our formula is 3 by 10 into 36 plus 1 by 3 into 40 plus 11 by 30 into 44. So see, if you solve it in this way, it will be a little hard to add them up, right? So it's your choice. You can do it, but if you would have written in this way, let's say 36 by 120 plus 40 by 120 plus 44 by 120, then it would have been easier, right? So now base is same. You can just directly add them up. So maybe 36 square plus 40 square plus 44 square, and then you have to divide it the whole thing by 120. You can find it out what this is.
Sir, 40 point.
Say,
Sir, 40.26.
yes. Oh, yeah. I need to add this. 36 into 36 plus 40 into 40 plus 44 into 44. So this will give me the numerator. This is my numerator. I have to divide it by 120. 120. That will give me 40.266. That is my expected 266 or 267 if you want to round it off or something. Okay. So this is going to be my expected mean. And same way you can find the variance of it. If you want to find the variance, say, let's say you want to find v of x. How will you find it? You will first find square. You'll do square of all the x's.
Expected.
Yes, and then from that you'll subtract the expected mean square. So this is 40.267 square, right? But this we have to find it out. So how will you do it? So you can maybe do 36 square, 40 square, 44 square, and then you have to find the you have to find expected value of this, right? So probability will not change. That is going to be still same. That 36 by 120, and another was 40 by 120, and third one was 44 by 120. Now you want to find for x square, which is 36 square, 40 square, and 44 square, right? And of course addition of all three. So now it become like cube of this and then divide by 120. Right?
Sir,
So
1632.
1632. This value is correct. So v of x will become 1632 minus square of this.
40.267.
No, the square of that. We have to take square of that.
Okay, yeah.
Yeah, this value, and have to take square of this. It's going to be 1621. So 1621. Okay, point something. Point, what is it?
443.
40.
43.
It's 4043.
43, sir. If you take exactly
Yeah.
40.267.
Yeah, then you'll get different answer. Okay. So I didn't round off there, so that's why I got 40. Okay. Now you have to subtract. So maybe this is going to be 0 and 1 point how much 7 5, right? So silly. So this is my variance of this random variance 10.57 to subtract. Okay, so that's how you'll get variance of it. You can plot and all if you like. It's a 36 and 40 and 44 and all. So at 36 you are getting probability also 36. 3 by 10 was there, 36 by 120. Say you can say this is 36 by 120, this is 40 by 120, and then you have 44 by 120. So be like this, and then a big curve. So this is going to be PMF, right? And our variance is or our expected value is coming out to 40.267, right? Which is right, like, so this was my 40 value, right? Right near, very near to it, like 40.267. You can also see that, yeah, I think that's what you will get, right? Because this is a larger value, so mean will be slightly in the right side of this. Okay, and the variance is how much it deviates from mean, right? That's what it means, which will variance maybe around 10, or standard deviation if you take, then that will be under root of this, right? Under root of this is standard deviation. Under root of 10, then you can say that will be much better indicator of variance, indicator of change in values, right? And then you will get something around 3 point something. So that is my change in values, right? So like this, you can see that, yeah, it does make sense if you plot and all. That this is going to be right. Now this is a question. Probability mass function was given to you. Asked for, so just for clarification, this is 2x plus 1 whole square, and then you have to find the expected value of that. Okay. It's not square outside like we did this expected value square. This is what being asked. You can go for it. What could be the value of it? I can give you a few minutes. Anyone trying that? Should I wait?
Yes, sir, just a minute.
Okay.
Done, sir.
Okay. Anybody else trying? Should
Done, sir.
we move? Okay. So what is your answer?
3.67.
0.67. Okay. Anyone else? Same thing or different? And we got anybody got different answer?
1.66.
0.66. Okay. Anyone else?
Mine is 3.6. Yeah, round up 3.67.
Minus or plus?
Plus, sir.
No, sir, no any other. You may
Oh.
continue.
Okay, this 2 only. Okay, let's see.
Yes, sir.
So x was given to us. This now they asked what is first you have to do what 2x plus 1, right? So first you have to do 2x plus 1, or here right 2x plus 1, right? That's what you have to find. How will you do that? So multiply this by 2 minus 2 plus 1. That will give you minus 1. Then same thing, you'll get 1, and here you'll get 2 plus 1, 3. So this is 2x plus 1. You have to do square of that. Okay, so if I do square of that, 2x
Sir, it will
plus
come
1.
0, right? The middle one. 0 into 1, 0.
No, 2 multiplied by x is 0, but plus 1 I have to do, right?
Okay.
2x plus 1. That's what it is. Then I'll do square of that also. So all of them, if I square, then I'll get 1 here, and here I'll get 9. Square of this values.
Yes.
2x plus 1. Now they are asking us to find the expected value of this. So you can maybe write, let's say this whole thing, y is equal to 2x plus 1 whole square as a y. Okay, and then p of y is nothing but same as p of x. Okay, this is going to be same as this. So here we got 119, or you can merge them also. So this both things are same. You can merge them. It's your choice.
How 119, sir? Sir, here we have minus 101 there for value of x.
1, right? That is our x.
Yeah.
Correct. We
Sir,
wanted
how
to find
119, how it becomes 119?
Yeah.
Square it, square.
So first we did 2x plus 1, right?
No, sir.
Then we have to.
Sir, we find
task.
expectation, sir, by multiplying x into p of x, right?
Expectation of
X into p of x by
yes. Yes.
Then how we got 119? I mean, even if it's square 010, then it will be 010, right?
I'm not getting your question. So we have this x, right? This is our x.
Sir, we have x, right? Even if we square value of
Yes,
x,
we have
then it will have 101, not minus 113.
Mul, we are not finding the square of x. We are putting the value in this function 2x plus 1.
Yes.
The value of x.
We can
We wanted
simplify
to find this, right? This is our question.
Yes.
Sir, we can simplify it now, a plus b whole square, right?
You can do that, a plus b whole square, but see, it will become difficult, right? If you have two things now. I mean, there's no issue with it. You can do that. But you have to approach. So, but you have to find this. What will be this? This is my y, right? You can call this x, and this is, let's say, y. You have to find this y. This values you have to find. You can do anyway. X plus. You can do square of them or anyway. Okay, that not a problem. But you have to find these values. So I did it this way, and that's how I got this values, y values.
Yes, important.
Sir, are you speaking, sir? Sir, we are not able to hear you, sir.
Hello.
Yes, sir.
Yes,
Now
sir.
audible.
That's audible.
Okay. Yes. So this is my now y, and p of y is given. So ask for 2x plus 1 whole square and expectation of that, right? And you can say maybe, expectation of y. So
Yes.
expectation of y is going to be
Same
summation of
then of the pen, it's very difficult to see.
what is pen, huh?
Sir,
Yes, sir. Pen.
sir,
So
You want
he's
white?
telling,
Okay.
yes,
he's telling about the blue color, sir.
Yeah, okay, fine. I'll use. So okay. So I had this y, which is 2x plus 1 whole square. Okay. And my p of y, which is going to be same as this. If I recall, this is 1 by 6, 1 by 2, and 1 by 3. You can sum it up, but they say this is PMF, so
Yes.
it is equal to 1. Okay. This we found 1, 1, and 9. Okay, so this is how
Yes.
we found this. Now expectation of y we have to find, right? So 2x plus 1, and that is going to be pi yi, you can say, and 1 by 6 plus into 1 plus 1 by 2 into 1 plus 1 by 3
1 by 3
into
into 9.
9, right? So you'll get if you do add this to 1 by 6, that is going to be 6, 1 plus 3, 4 by 6, that is going to be 4 by 6 plus this is 3 only, and 4 by 6 is 2 by 3, and 2 by 3 is, you can say, 0.66 or
Yes.
0.67, 0.66 or 67, and right,
Yes.
plus 3, so that is going to be 3.67.
3.67.
Okay. So this is the correct answer. This is correct, this is not correct. So this too asked in previous term, end term, that how do you find this? So this covered, I think, only expected value was asked, but we did variance also. So you know how to find variance, you know how to do it, and then let's say if they do change something with uh, expect with x, that they give a different formula of a different function of x, then how will you do it? So you can just call it as y, whatever given inside of this, and then you can find it. Okay? That's not a big issue. Yes, so that's all covers in week 9 and 10. Okay, we covered previous term questions. Yes. So that's all from my side.
Okay.
will there be any revision session for sir week 1 to 8?
Week 1 to 8, no. We already did week 1 to 4. Then I think we did 5 to 8 also. Now we are taking 9 to 10 and then 11 to 12. Right? So we already did it week 1 to 4 and 5 to 8 separately. You can check the calendar. I think it's
Okay.
written there.
So can you please solve that variance value which you had done very earlier in this lecture?
Yeah, sure. So we had this pen. We had this x and p of x as 0, 1, 2, 3, 1 by 8, 3 by 8, 3 by 8, 1 by 8. And I said v of variance of x is going to be summation. You'll take probabilities and xi minus expectation of this whole square. So let's do this. So first one was probability will, right? Let's say 1 by 8, and expect value was 0, and expected value was e of x was 1.5. Okay. So I'll subtract 1.5 out of that and square it. Then probability is 3 by 8. My this one is 1 minus 1.5 whole square plus again 3 by 8, 2 minus 1.5 whole square, and last one is 1 by 8, 3 minus 1.5 whole square. So like 1.5, this will give you 1.5 whole square, which is 2.25, right? 15 square is 225, and you can do it. So this will give me that. And here you'll get, from this, you'll get 0.5. And if you square that, 5 square is 25. So from that, you'll get 0.25. Okay. So I'll write directly like 1.1 by 8 into 2.25 plus 3 by 8, you'll get 0.25. 3 by 8, 0.25 plus 1 by 8, and you'll get 2.25. Okay. And that is how much? 2.25 plus 3 times of this is 0.75. 0.75 plus 2.25 divided by 8. Okay, so this you will get from this. And okay, if I sum it up, this is 3. This is also 3. So this is 6 by 8. 6 by 8, and we are getting how much? 3 by 4. This is 0.75. And what we'll get if we do e of x square, sorry, e of expectation of x square, I have to subtract e of x from that whole square. I think we already found that. 2, 4, 9, and from this you'll get e of x square is going to be 3 by 8 plus 12 by 8 plus 9 by 8, and you'll get almost 12, 24 by 8, just 3. 3. 3 you got, this is 3, and this is 1.5 whole square, which is 2.25, right? 2.2, 2.25, and you'll get 0.75. So both of them will give same answer. Okay.
Okay, sir. Thank you so much.
So yes, so that's all from my side. If anything else from week 9 and 10. Okay. Thank you then. Can close this.
Thank you, sir.
Thank
you, sir.
Sir, one more last question, sir.
Yes.
Which was I sent in the message box, sir.
Okay.
This is a practice question from week 10.
It's about, okay. So there are 5 numbered cards in deck. So they are saying that 2 power 5, which is 32. Power 4 is 16, is 32, right? So 32 numbered cards are there in a deck. So I think they've taken card deck, right? So card deck has numbered cards. One then 52 cards are there, and 32 are numbered. Then you can say maybe 20 are face cards. So let's say king, queen, jack. I mean, I'm just making sense that is it about that, or is it about the thing? Among which 5 CR cards bear the number this 01025. 10 cards are drawn with replacement. What is the expectation of some of the numbers? Uh, 2 power 5 is that. Check among which 5 CI cards bear 0125 from the deck. 10 cards are drawn with replacement. Uh,
5C
yeah,
zero
I
cards
think
have zero.
yes,
Likewise,
but
all.
okay. So first thing, this is random variable, but you need to know I think hypergeometric or something like that. Okay, which will solve this. This is not just a random variable. It's a see with first thing is with replacement is there. So this will not change the probability uh, of each event, but this is not just the random variable. When week 11 and 12 will be covered, then you will be able to solve this.
Sir,
So,
but
so
this
you'll,
one is in the week 10 graded assignment, first question.
is it okay? Okay, then we can try. But, right. So we have 32, and among which 5 CI cards, this one. 10 cards are drawn with replacement. So they just said that it's nothing to do with the card deck. I thought I was related to that. Okay. 32 cards are there. Total 32 cards are there, and out of that, uh, some number. Okay, so let's say 5C I cards bear the number this 025 0 0 1 2 3 4 5. Okay. Now, yeah, 32. 10 cards are drawn with replacement.
Sir, I understand 5C0, which is 5 cards having the number 0. So then, likewise, we need to, the 5C1 number of cards has the number 1.
So 5C1 is also 5, right? 5C2 is 10. 5C0 is 1 only, right?
1.
1, 5, 10. This is also 5, 1. What is this? 5C.
10.
But yeah, this is going to be 5. Oh, this is also yeah. Yes. So how many 20? 32 cards. Okay, this is 32 cards. And now we are drawing 10 cards with replacement. So
Now we can get the probability.
Yes, but okay, so we need to see. Okay. Yeah, we can get probability of this. 10 cards are drawn. 10 cards will be drawn. This first. The drawing probability will not change. This is going to be 1 by 32. This is also going to be 1 by 32. By 32. Right? So there nothing is changing. Okay. 10 cards are drawn. But some of them was probability we can find, but
Probability of getting 0 numbered cards is 1 by 32. Can say it again.
yeah, that is okay.
Then 5 by 32.
Yeah, that's okay. We can write this, but
Is they are asking 10 into e of x?
There are some 10 into this, right? So if I draw 10 cards with replacement,
The expected value is 2.5, sir.
so what is P in that? I mean, you found, okay, so for this, you can find E of x, or say maybe, P of x equal to 0, x 0, like something like that you did it.
Yeah, did it, sir? At the last AFX equal to 80 by 32 I got, sir. When I divided it, I got 2.5. I got it clear. I think I'm clear now, sir. I'm just multiplying with the 5 cards. I mean 2.5 into 5. That's why I get a wrong answer. Instead of 5, if I multiply it with 10 cards, which is 10 cards with replacement, I got the correct answer, sir. 2.5 into 10, I got 25, sir. The answer range will be, wait a minute, sir, 24.9 to 25.1, sir. Okay, sir.
Okay,
I'm clear, sir.
okay. I think I got it. So yeah, the thing is, okay. We will first find the probability of this, which is 1 by 32, 5 by 32, and 10 by 32, and what same thing, right? Now, see, this is a probability of drawing a card and all, but what you are doing is you are doing like we did, right? We had with the coins, we had this experiment. If I repeat it 10 times, then what will happen? Something like that. So whatever expected value I get, multiply by that value, right? So that is like in reality I can expect that number. So that's what they are asking. So if I have E of x of this, whatever E of x you get from this, you just have to do multiply by 10. Why we are doing it? Because they are doing with replacement. Okay, that is important. If they have done without replacement, yes, then it's not a simple answer. That then you have to go. Then it will be very different. Okay, because now everything's changing. So that's why you have to do with multiply by 10. So this is just one experiment of that. You can draw any card, right? You can draw a card, and the probability of that is this, and you are doing the same thing 10 times, drawing the cards, drawing the card 10 times. You keep it back, maybe shuffle it, and then picking it up. So that's why it is multiply by 10, and from this you will be able to figure it out what is the expectation of sum of the numbers.
Expected value is 2.5, sir. With into 10, it is 25, sir.
25. Okay. Yes, then it is 20.
Okay, sir. Thank you, sir.
Week 19. It's not uploaded. Week 9, 10, 11, 12. Graded assignments. So is graded assignment solution uploaded
Yes, sir.
for all the weeks 9, 10, 11, 12?
Not full, sir.
Yeah, whichever is over, for which deadline is over.
11, sir. 11.
Till 11 is there, right? So yeah, I think solutions, right? You got the solution.
Yes, sir.
Bridges is asking so. Okay. Thank you then. Stop sharing.
Okay, sir. When was the next, week 11 and 12 revision?
It's already updated in calendar. You can see.
It mentioned only 9 and 10, sir. Otherwise, it shows
on August
yes, sir.
28th, right? It's mentioned August 28th.
Okay, sir.
Wednesday.
Maybe I missed it. Okay, sir.
Oh, thank you.
Thank you.
Bye then.
Thank you.
Thank you, sir.